In today's lesson, we are going to continue solving percent problems using proportional situations, right? Because percent is a special ratio out of 100, and we can create a proportion and solve problems. Now, there's a few things and a few ways that tips I'll give you to help us make some of these problem-solving situations a little bit easier. Here's the first situation. A coat with an original price of $85.50 is reduced by 15%. The new selling price of the coat is, well, what most of us have been doing is finding 15% of $85.50. We've been finding the discount, and then we're subtracting that discount from the original price to find the sale price. So it takes two steps. It's not wrong. It's not too bad of a step, but there's another way we can do it which will help us when we get to more difficult problem solving. This is a good concept to learn. So rather than finding 15% and finding the discount and then subtracting, well, we can say, well, we know we are reducing it by 15%. So if we are at 100%, the whole price of the jacket, and we're reducing 15%, well, we are really paying for 85%. So by subtracting the 15% from the original, we now know what part we are paying for. So what we can do is instead, we can just say, well, let's find 85% of the original jacket, right? 85% is 0.85, and so 0.85 multiplied by 85.50 is $72.68 rounded to the nearest cent. That is the sale price. It is 85% of the original price. Here's another example. Bob earns $25,000 a year, and Frank earns 6% more than Bob. What amount does Frank earn? Well, just like we were doing before, we could find 6% of our $25,000, and then this would give us how much more Frank earns, and then we would add that to the $25,000. And again, that's perfectly correct. But what we could start to think and take it to the next level is say, okay, well, Bob earns 100%, the total, right? The starting point. This is the 100%, because Frank earns 6% more than that. So we take the 100% and we add 6%, right? Since it's more than, we're not subtracting, we're adding. So Frank earns 106% of Bob's earnings. So now we can find, instead of 6% and adding it to it, we can just say, well, let's find 106% of 25,000, right? Which is 1.06 multiplied by 25,000. So we take our calculator, and so basically when you're multiplying by 1, you're keeping that value and adding on 6% to that value, right? And so we get the total value, which includes the extra. All right, let's skip down to another question that's helpful like that. Let's try this one. My investment of $5,500 earns 6.5 interest compounded annually. Okay, so compounding means that the money I make, the interest I earn, stays in the bank, and the new interest I make is calculated on my new balance. So I don't take the interest out. So I don't just keep this balance every year. I'm going to earn some money, my balance will go up, then I'm going to earn some money on my new balance. So interest calculated off of the new balance plus the interest. So what is my balance after 1 year? Well, I have $5,500, and again, I'm increasing it by 6.5%, right? I'm not just earning 6.5% and having only the interest in the bank. I'm going to have this plus my interest in the bank, because it's my money's going to grow if it's an investment. So I'm going to have 100% plus my 6.5% in the bank. In other words, I'm going to have 106.5% of what I had at the beginning of the year at the end of the year. So I can take my 5,500 and I can find 106.5% of this. Or in other words, if I divide by 100, I get 1.065 of that. So if I calculate that 1.065 multiplied by 5,500, I get $5,857, and it says 0.5 on my calculator, but since it's money, I'm going to write 50 and 50 cents. That's my balance, how much money I have in the bank after 1 year. So now, if I'm not going to take that out of the bank, I'm just going to leave it in there because I don't need it, it's an investment. I'm going to now see how much money I have in the bank after 2 years, or what my balance is after 2 years. Same interest rate. So now my new balance is $5,857.50, and I still have the same interest rate. So at the end of the second year, I'm going to have 106.5% of what I have in the bank there. Right? Instead of writing that, I'm just going to divide by 100 again and write 1.065, right? Without the percent sign, I divide it by 100. And now I calculate that. And I have $6,238.24 after 2 years. All right. And so if I wanted to know how much money I made in total, I could take this value, subtract my original, and that's how much interest I have earned after 2 years. If I wanted to know how much interest I earned after 1 year, I could take this balance and subtract my original investment and find out how much interest I made after 1 year. All right? So the next thing I want to talk about is, don't forget, if you ever forget what to do and how to find something, we can always go to this proportional situation where your percent, something like 27%, your percent always goes over 100. So 27% I would write as 27 over 100. That is my percent part. I know the percent, so I can fill in that entire fraction. Then I have to fill in the part and the total. The part is the one that equates to that percent. It's not always the smaller number, right? If my percent was 20%, it would be smaller than that. But if my percent was 150%, the part would be bigger than the total, right? The part is the proportion that you have out of 100. The total is what makes up the whole thing, right? A little tip, the word is usually comes before the part, and the word of usually comes with the total, either with the number or in the words, the conceptual part of the word problem. So 12 is 27% of what? So the 12 is the 27, so it goes on the top. It's the part of something. We don't know what that is, so we put X on the bottom. So we have set this up in a proportional situation in which we could say, how am I getting from 12 to 27 or 27 to 12? Do the same thing. We could cross multiply. We could go X times 27 equals 12 times 100. Divide both sides by 27. And we would get 44.4 repeater, or 44 and 4/9 is the total, right? That's one way you could do it. There is another method you could do it. We could use our, 12 is 27% of what number? 27% of what number is 12? We could write it out more algebraically. Well, 27% of some number is 0.27 multiplied by x. 0.27x equals 12, right? So if we know the percent of the total equals something and we know the answer, we can use our algebra skills to find x. We could divide both sides by 0.27. And we get the same answer as we had over there. And so there's two methods, using your proportion or using your algebra skills. Okay? Doesn't matter which one you use, it's your choice. So here we have 24 out of something. 24 out of something, whoops, is 30%. So whenever you see the percent, you know the entire fraction. You know it's 30 over 100, right? That goes together always. So now again you can solve. Oh, 30x equals 2400. Divide both sides by 30, and we get x is 80. 24 out of 80 is 30%. So sometimes you need to find what the total is when you're given the part. Okay? Sometimes we find the part when we're given the total, and sometimes we find the percent when we're given both the part and the total. Those are the three different things I can ask you. 100 is always there because in percent, that's what it means, out of 100. That part is always there. 3 is 2/5% of what? Well, the 3 is the part of something. Again, we don't know. 2/5%, well, the 2/5 is out of 100, right? We can leave it as a fraction 2/5, or since it's a terminating decimal, rather than writing 2/5, we could always write 0.4, right? 2 divided by 5. So 2/5% is 0.4 out of 100. So we could cross multiply, divide both sides by 0.4, and so now, oops, I'm missing my x in there, and now I get x is 750. So that means 3 out of 750 is equal to 2/5%. John received 90% on his last math test. He got 63 questions correct. Okay? So the 63 questions correct reflect the 90%. We don't know how many questions were on the test, so we could set that up. 63 out of something equals 90 out of 100. Right? Because we know the percent, we just don't know how many questions were on the test, right? And so again, whichever method you choose, you can. I've been doing the cross multiplication one, but at any time you could say, well, I know that 0.90 of something equals 63, therefore x is 63 divided by 0.90. You could always use your algebraic method, but I'm just going to keep using this way. But if you like the algebraic, you can. And so we get that x is, there are 70 questions on the test. He got 63 out of the 70 to get 90%. The sale price of a bike was $260 after a 15% discount. What was the regular price of the bike? This is a question where what I taught you earlier really helps, because we can't take 15% of something. We don't know what the discount was. We just know the sale price. And since we know the sale price, we know what we paid for. We do not know how much we saved, right? So if this is the sale price after a 15% discount, the sale price is 85% of the original. And this is where that little concept really helps us, because we can set it up in a proportion using 85%. This 260 is 85% of the original price. So 260 out of what equals 85 out of 100. And then we can solve it. 85x equals 26,000. And we get that x is $305.88. That was the original price. Taking our 15% discount got us to $260. Here's another example. If the price of a watch is increased by 20% to $150, what was the original price? Again, I don't know how much money it was increased by. I just know it was increased by 20% to get to $150. So what was that original price? Well, since it was increased by 20%, the $150 represents 120% of the original price, right? Because it was increased by 20. So now again, I can set up a proportional situation using the 120, right? The 150 sale increased price as compared to the original is 120, right? 20% increase over the original of 100, right? From 100 to 120 is a 20% increase. Again, cross multiply. And so we get 15,000 divided by 120. I get that I have a $125 original price. Okay, so the 20% increase was $25. I didn't even need to know that. I just wanted to know the original price. Make sure we understand what I mean by percent increase and decrease as well. So the percent increase is how much over 100%. The percent decrease is how much below 100%. And it's always based off of where you were in the beginning. So if the percent increase is always based off the lower one because you're increasing. The percent decrease is always based off the higher one because you were decreasing. For example, what is the percent increase if we're going from 50 to 200? Well, my increase is $150, right? And so my increase will be how much I went up by as compared to, right? That's the increase as compared to where I started, or the original. And the original in this case was 50. And so I want to find a percent increase. I want to make it out of 100, right? So in this case, it's an easy one, just double, or whenever you have a fraction and you want to make it into a percent, you can just divide and multiply by 100 as well. We have gone through lots of different strategies. So I'm getting a 300% increase, right? In other words, it is tripled. The increase is triple. Let's try this one, but I'm going to change this one around so that I made it into a decrease. So let's say it started at 90 and went to 80. So you can see that that's a decrease in price. Well, how much did it decrease by? It decreased by $10, didn't it? As compared to my original $90. So this time you started at 90 and went to 80, so I have to compare it to the 90. And so I want to make that into a percent. So I get 11.1 repeater percent, so about 11% decrease. So percent increase is how much it went up by as compared to the starting. Percent decrease is how much it went down by as compared to the start point. So for example, a number of students attending French immersion schools increased from 1,600 to 3,800. What was the percent increase? Well, you have to take your 3,800, subtract your 1,600, and you're going to get that the number of students increased by 2,200 as compared to the starting of 1,600, and I'm going to change that into a percentage. And I'm going to get, that is a 137.5%, and you have to use the word increase because it's not 137.5 of the original. It's the increase is this percent, right? So it increased by almost 1.5, right? The increase is 1.5 the original. Okay, it's not 1.5 of the original. Okay. Because you can see that it's actually more than double in total. Let's try this last question here. This year, Jaslyne's song collection increased by 40%. She has 420 songs in it now. How many songs did she have before? Well, here's another example where we know what it is now, but we do not know the original. So we know she has 420 now, but we do not know how much she had before. It increased by 40%. So if she had 100% before, she now has 140% now, because the increase means she has 40% more than the original 100. And again, we can cross multiply. 140x equals 42,000. 42,000 divided by 140 is 300. Oh, she had 300 songs before. So when you have a question a problem to solve, you want to set it up in a proportional situation. If you see an increase or a decrease, you have to put in the appropriate increase or decrease there to complement whatever you've been given in the